Okay, so first things first, have a look, please. Okay, what I'd like to do before we jump into the new stuff, there were a couple questions on the 4-2 assignment. I wanted to hit that real quick. So on the 4-2 assignment, when you see stuff like this, here's some questions off of this. So these were all pretty similar kinds of questions. They're going to give you two triangles. They're telling you a triangle congruence relationship. So they're telling us that triangle TJM is congruent to triangle PHS. Now remember, when we write a triangle congruence like that, it's not like it was with segments or angles or something like that, where it didn't really matter the order in which we wrote the vertices, right? If I wanted to say, for example, that, if I wanted to say that angle T and angle P are congruent, I could say angle T is congruent to angle P, or I could say angle JTM is congruent to angle P, or I could say angle MTJ is congruent to angle P, right? There's lots of different ways I could say it, and they'd all be right. With triangles, it has to be way more specific, because with triangles, we have to line up the corresponding parts, corresponding vertices or angles, right? So when we write the congruence like this, it's telling us that angle T is specifically congruent to angle P, because T and P both are the first letters, right? So I could say this. I could write in this congruence. What's another pair of congruent angles? J and H. Good. J is the middle letter and H is the middle letter, so I know that J goes with H. Then the third one would just be M and S, right? Okay, what's a side that's congruent on both? What's a pair of sides that would be congruent between these two triangles? H. Okay, so H and J would be angles. If I'm going to say a side, how would I name a side here?
Side HS.
Okay, so side HS, for example. So HS would have to go with JM. Good. So I could say this. I could say HS and JM are congruent. What's another pair of sides that would be congruent? Okay, so SP and MT. So SP, MT, those would be congruent. And then the last one? Okay, so like TJ and PH. So from that triangle congruence relationship, we know that if those triangles are congruent, all three pairs of angles and all three pairs of sides would have to be congruent, right? So we're going to use that information to answer this. Now let's look at the question that's being asked here, because this is another thing that I think people had some issues with. Now you got to be careful with this. What is that asking about? What does this mean when we have a symbol like that? The measure of angle H, right, is equal to, not congruent to. The measure of an angle is a number, right? So numbers are equal, geometric figures are congruent. So we're expecting back a number, aren't we? Right? So we could fill in some information here. What do we know? We know the measure of angle S is 50 degrees, so I could write a 50 degrees there. Where else could I put a 50 degrees then? M. We know that the measure of angle T is 74 degrees, so if this is 74, P is also 74. They want to know what the measure of angle H is. Well, how am I going to find that? Say it again. Okay, I could find the measure of angle J, and then they'd be the same. Cassie? Okay. So 50 plus 74 is 124 degrees. Keep going, you're going to get it right. Good. We know that by the triangle sum theorem, the measures of all of the interior angles of a triangle, always 180. So if I just subtract this number from 180, that's going to give me whatever's left over for the third angle, right? So if we subtract those, I'm just gonna get, what, 56 degrees, right? And so I know that has to be, whoops, that's my answer, right, 56. 56, and they already provided the degrees symbol there, so I just have to put in the 56, right? Make sense? Okay. What about, oops, oh. What about one like this? Different, right? This time they're wanting to know, it's a different kind of question. What does that mean? Angle P is congruent to fill in the blank. So this is not a measure, this is a geometric thing. This is a figure. So I've got to provide in my answer, not a number, but I have to say whatever angle is actually congruent to angle P. Well, which one is it?
T.
Angle T. Good, so in Moodle I would have to input, how do we do an angle? Angle, no spaces, right? So I just go like that. Okay, make sense? Okay,
Wait, that's the answer?
that's the answer. Yeah. Right, because
I don't.
angle P would be congruent to, angle P is congruent to angle T,
Oh.
right? See what I'm saying?
Yeah.
Okay? But they don't want a number this time, they want to know what is the actual angle. Okay? Not to measure the angle. Okay, what's that mean? What's that symbol mean? Okay, so not line though. What does that mean if I have a straight side or segment? Either one, right? Side or segment. In this case, side probably works best because it's a triangle. But either answer would be okay. So side MT is congruent to, so are they expecting back a number?
No.
No. They want to know what's the other geometric thing that's congruent to side MT. What's it going to be?
SP.
SP. Good. So our answer would be side SP. Or, if we want to, we could say segment SP. Either one should work. Okay? Questions? Oops. Oh. Okay, we can skip that one. Already did that. Okay, what's that saying?
Triangle.
Okay, so triangle SHP would be congruent to, well, we already know that triangles are congruent, but we have to write the congruence relationship properly, right? The congruence statement. So that's going to be triangle what?
JT.
Okay, and how would we do that in Moodle? Triangle. No space. And then S goes with M, right? H goes with J, and P goes with T. So triangle MJT. Okay, make sense?
Why is it backwards like that?
Well, because this one was written backwards,
Oh, okay.
right? So if we want to write the triangle that's congruent to this triangle written in that order, I have to have the corresponding order. Okay? One more kind. Yeah, what about that one? So what does that mean? When I just have two letters next to each other like that, what's that mean? Okay, it's not a line and it's not a segment, it's something different. It's a length, isn't it? Yeah, we can either think of it as being a distance between the points, or in the context of a problem like this, the distance between the points is really just the length of the side, isn't it? Right? So that's a number, isn't it? And we know it's a number because look, it's an equal sign. So we want to know JT is equal to, then it's a number, right? It's not a geometric thing, okay? So let's see, we could fill in some blanks here. We really don't care about the angles this time, I guess, do we? We just care about the side length. So they tell us that SP, side SP, has a length of 28. So SP, side SP is congruent to what side on the other triangle? SP would be MT. Okay, so those are congruent. So I know that MT has a length of 28. Am I given any other information here about sides? I'm not, am I? And there's really no way to find the other sides. I mean, maybe if these were right triangles and I had two of them, I could use Pythagorean theorem or something, right? But they're not. I'm only given one side. So when they ask for JT, do I know? No. So what do the instructions say to do then? NA. Yeah, if you can't determine the value, then the answer's NA. Okay? Make sense? Okay. All right. Okay, new stuff. Okay, so what we're going to do here, let's kind of think about what we've done in the past. Is this better? Is that too dark if I do that?
No.
Is that better? You can probably see it better. Okay, so what we want to do, we're going to add some shortcuts, right? We're going to add some shortcuts. What we've done in the past, we've always had in the past, until now, triangles, we could only show that triangles were congruent if all of the sides and all of the angles were congruent. That's how we knew that triangles were congruent. All the corresponding parts of one triangle were congruent to the corresponding parts of another triangle, right? Not anymore. We're going to start adding some shortcuts. We're going to give you 2 shortcuts today where we don't have to have all 6 parts of each triangle. We can only have a certain combination of 3 will work. And there's some different combinations that work. Okay, one of the shortcuts is SSS, side, side, side congruence postulate. We'll just call it SSS, or side, side, side. What this tells us is that if all 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle, that's all it takes. We don't have to know any information about the angles. If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then they're congruent. For this reason, by SSS. Okay. So for example, in this situation right here, look what we've got. We know that side AB is congruent to side DE or ED. We know that, whoops. It's kind of annoying, isn't it? We know that side AC is congruent to side EF, and side BC is congruent to side DF, right? And so therefore we know that because these 3 sides in this triangle are congruent to the 3 sides in this triangle, they have to be congruent. The angles just have to work. We don't need to show that. Okay? So can we take a situation like this? Let's just do some really simple proofs here. Can we prove that those 2 triangles are congruent to each other? Well, look what we're given here. We're given, if you look at the congruence marks, we're told that 2 sides in the left triangle are congruent to 2 sides in the right triangle. So we're almost there. But it's pretty easy to get one additional piece of congruence there, isn't it? What can we do?
Do you even need the 10 since the others up in dark blue?
You do, because think about this. Now I could change. Let's say this is a pivot point right here, right? And this is like a rubber band. If I were to swing this segment out this way, these 2 sides lengths would stay the same, wouldn't they? But this one would change, right? Does that make sense? So I do need to be told that they're both 10. But if they're both 10, what's that mean? They're congruent, right? By the definition of congruent segments, if they have the same length, they're congruent, right? So I can add a 3rd congruence here, which saves the day. Now I've got SSS, right? Look at the congruences in each triangle. S, 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 right? Congruent to SSS. So the triangles have to be congruent. Now if I wanted to, that's pretty simple. If I want to write that up as a proof, what would that look like? Well, I'd have to, what am I given? First thing I'd have to do is state, what am I given here? Well, I'm given all that stuff, right? They gave me a bunch of stuff. They gave me 2 segments being congruent, and they gave me 2 lengths equaling 10. So then all I'd have to say is that segment QS is congruent to segment US by definition of congruent segments, and then I'm essentially done.
So how do you answer a question?
Good question. Okay, so how do you answer? Well, I'm not gonna give you guys very many of these, but at some point I'll give you a couple of them where you'd have to just maybe fill in the reasons for the proof. That'd be like off that purple sheet. But other questions, you'll see in a second the kinds of questions you're gonna get on the assignment. I'll point it out when we get one like that. Does that make sense? Okay? And really, well actually, maybe I can answer it now. Really what it would have been is I would have given you this picture up here, and I would have said something like, can you prove those triangles are congruent with a congruence relationship? And if so, which one is it? If not, type, enter NA. Well, we could, right? We could see that those are going to be congruent, and so I could easily get this to where I have side, 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 and that would be my answer, SSS. Does that make sense?
Yeah.
Okay. Here's another one. Oh, here, another postulate, or another relationship. We had side, side, side. Now we're going to add side, angle, side. But you got to be careful with this because the order is important. This doesn't just mean 2 sides and an angle. It means 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle. So for example, this would work here, right? Because here, if you look at the order, I've got side, if I'm walking around the edge of the triangle, I've got side, angle, side in the left triangle congruent to side, angle, side, right? So it would have been different if this angle had been like up here. It wouldn't have worked because then it would have been a different. See what I'm saying? Let me draw it rather than talking about it. Let me draw it. So what if we had this triangle instead? What if we had triangles with this congruence relationship? Say we had that one. That doesn't work, right? Because now it doesn't fit the pattern. That would be angle, side, side. That's not our pattern. Side, angle, side, right? Okay, what about these? So the question you would get then is, could these 2 triangles be proved congruent? And if so, what would be the congruence relationship? The congruence reason, let's say. We're only given 2 things. Can we add a third one? What would it be? Vertical angles. So angles 1 and 2 would be congruent because they're vertical angles. And just real quick, remember what that means. If I've just got 2 segments or lines or whatever that are crossing, so only 2 of them are crossing though. We're not worried about anything complicated like parallel lines and transversals. I've just got one intersection between 2 lines or segments. Then opposite angles are called vertical angles, remember, and they're always congruent. So we could say, yeah, these angles are congruent, and then it fits the pattern, right? What's the pattern going to be? SAS. Side, angle, side, congruent to side, angle, side. You see what I mean when I say this is side, angle, side? It means if you walk around the outside, that's the order in which you hit the congruences, right? 2 sides and the included angle, right? Questions? Okay. And so if we wanted to write this up as a proof, we've got this given information, but then we could say that angles 1 and 2 are congruent by vertical angles theorem, and then I have side, angle, side, right? SAS proves the triangle is congruent. Okay. Okay, what about this one? Can I prove those triangles are congruent? I'm only given two things, so I gotta fill in, if I can, I've gotta add one more congruence. What would it be? Angle? Which angle? What do you think? Anybody see an angle? Q and S, they look like they're congruent, but I'm not told that. And I don't have any reason to support that. And maybe if I had like parallel lines and I could use some of my chapter 3 stuff, but I don't really have anything to get an angle there, unfortunately. Can I get another side?
Yeah.
How?
R and T.
Oh, okay, because look, they share a side, don't they? Right? If they share a side, then RT is a piece of both triangles, and so that side is obviously congruent to itself, isn't it? And the reason for that, remember, we haven't used this in a long time, but if we go way back to the very beginning, we had a property of congruence called the reflexive property, which just says that any geometric thing is always congruent to itself. It's easy to remember because if you look in a mirror, you see your reflection, which is congruent to you, right? Same size and shape, right? So we can just do this. We can add this third congruence because it's shared by both. Now, that might seem a little confusing, but maybe what's helpful is to pull the triangles apart. And this is a good trick in geometry. When figures are kind of mashed together and they share a side, or they share multiple things, you can pull them apart. So what if we did that? Then these triangles would look like, I'll draw them a little smaller, but they would look like this, right? And look at the congruences we get. So we've got these sides are congruent, those sides are congruent, and now that we've pulled it apart, side RT shows up in both triangles, right? Is that easier to see? So side, 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 right? So if we were to write it up as a 2-column proof, we've got our given stuff, and then we could say that this side is congruent to itself by reflexive property of congruence, and we're done. Then the triangles are congruent by SSS. Okay? Okay, what about this one? This is even trickier. I'm only really given one congruence this time, so I'm going to have to add 2 of them. Any ideas there? What do you think? Anybody see another one? Bailey, you got an idea? Do you see anything else we could add there? If I think of the left triangle and the right triangle, all I know right now is that side AR and side GR are congruent. Anything else that would have to be congruent between those two?
Since they share a middle line.
Okay, yeah, right, they share, everybody see that? So they share a side, right? So that's a freebie, right? They share side DR, so if I pull these apart, then DR would be congruent, right? We need something else. Ah, right angles, yeah. Now look, if this is a right angle, how do I describe these two angles? They're a linear pair, right? So they're supplementary, they must add up to what? 180, well if that's 90, what does this one have to be? 90, yeah. So we got it, right? And there's even a kind of a shorter way of saying that way would work. So, does that make sense? So now what's gonna be the congruence reason for these two triangles? Side angle side, yeah. 2 sides and the included angle of each triangle are congruent, right? So if I wanted, once again, if I wanted to write that up as more of a formal proof, I'm given some stuff. I know that they share a segment, so by the reflexive property, I can say this. And then I know that all right angles are congruent by the right angles theorem. That's one on our purple sheet. So I can add that. And then I got it. My side angle side. Okay. So there's 2 of them. We got side, 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 and side angle side. Now there's two more that go with them. Okay, we get two more. We get angle, side angle, and angle, angle, side. So let's look at all the possibilities then that we have, right? We're gonna have four of them. Okay, think what they are. So what are they? What are our four congruence relationships for triangles then? We just had which two? Side, side, side. SAS. We're gonna get two more. We're gonna get ASA and AAS. The math gods in their infinite wisdom have seen fit to not make this uncomfortable for math teachers. So the two that we don't get are angle, side, side. Fortunately, thank goodness, that's not an option. And angle, 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 right? Those are the two that don't work. Angle, angle, angle doesn't work, because if you think about this, what would happen if I took a little triangle and I just enlarged it? Well, we could still have congruence between all of the angles, couldn't we? But the triangles are clearly not congruent. Does anybody know what they are?
Oh, that one big one.
They're similar, yeah. We haven't gotten to that yet, but they are similar, but they're not congruent. So thank goodness those don't work. Those are our only options. So our only options are the ones that either don't spell a bad word and they're not angle, 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 right? All the other possibilities are free game. It really doesn't matter the order, does it? I mean, I could write this one as SAA. It'd be the same thing, except that the thing is, the correct answer is going to be AAS, because that's what we call the theorem, right? So if you happen to go the other way around, that's okay. Just reverse the direction, okay? All right, so take a quick look at these. So we've got angle, side angle, just tells us if we have two angles and the included side of one triangle are congruent to the corresponding stuff in another triangle, then they're congruent. And angle, angle, side, and be careful with this one, it's two angles and one of the non-included sides, not the included side, right? If I walk around the outside, the congruence is that the order in which I would encounter them would be an angle, then another angle, then a side, right? Okay, those both work. So, could we prove that those triangles are congruent? Well, given two things, is there another pretty easy, Savannah, do you see anything else we could get there? Any other congruences? Think about our angle relationships that look for intersections and things like that. Vertical angles, good. Yeah, we got vertical angles here in the middle, don't we? So we could go like that. Does that work? That's a pattern, isn't it? Because now if I walk around the outside, I could get angle, angle, side, congruent to angle, angle, side, right? Okay, so the answer would be AAS. If we looked at a quick proof, we've just got some given, oh, no, I guess there isn't a quick proof. I don't need it, that's all right. What about this one? We're given one thing. Can we add some other stuff? Let me see another congruence we can add. Shared sides. Okay, so we could add this. Now we got two things. Is there anything else? Unfortunately, there's not. That's too bad, there's not. So this would be an example where it'd be NA. We can't prove these congruent. Okay. What if we change this just a little bit? Does that make sense? We only got two, we needed three. There wasn't enough there. What if we tweak this problem just a little bit, make it look like this? Okay, now look what they tell us here. They give us a bunch of information that we can draw onto our figure. We can add some information. So they tell us that side, and this isn't exactly right. I should have that symbol there, shouldn't I? Side UZ, what's that mean? is parallel to side WX. So UZ parallel to WX. I'll add an arrow there, right? And then we know that side UW is parallel to side ZX. So I can add 2 arrows there. Okay, that might be helpful, right? Does anybody see, well, without having to worry about the parallel stuff, was there a really obvious congruence that we get right from the beginning? We always want to look for things like shared sides, right? Do they share a side? Yeah, they do. So we get 1 right here. That's a kind of a freebie. But we need 3 things. That's only 1. Now what about the parallel part? Does anybody see some angles that would have to be congruent? Tyler, do you see any angles that you think might be congruent? It's a little tricky, but anything up there?
I don't see.
Serena, see anything?
Right.
Okay, they look like right angles, don't they? And you know, maybe we could eventually get to those, but there's no way for us to directly say that they are. They just look like they are, but that's not enough. Okay, suggestion is 1 and 4. Okay, that's correct, but why?
Alternate.
Okay, alternate interior angle, right? Theorem. We'll just say alternate interior angles, right? So, how can we see that a little easier? Here's a trick. What I think is sometimes a good idea to do is so we must have used the top and the bottom parallel lines. It makes it a little easier to see if you extend those parallel lines and the transversal. So if I extend those guys out, tell me if this doesn't help a little bit. And then this is our transversal. And so really what we've got then is something like this, right? Where those angles right there are what? Alternate interiors, right? So they're congruent. Remember back to chapter 3, we had a whole bunch of relationships. If we started off and we said, if parallel lines are cut by a transversal, then get a whole bunch of stuff, right? Among that stuff, alternate interior angles are congruent. So we got, that's good, we got 1 and 4. Now we got 2 things that are congruent, but we need 3. So let's backtrack just a little bit. Any other angles that we could get? 2 and 3. Yeah, we get 2 and 3, can't we? And same deal. If we just extend the other set of parallel lines and the transversal, now we can see that 2 and 3 are alternate interior angles, right? So is that enough information? Look at the upper left triangle, for example. What's the order of the congruences? S, A, oh sorry, A, S, A, right? Does that make sense? I've got 2 angles in the included side of the upper triangle and 2 angles in the included side of the bottom right triangle. So yeah, they are congruent by ASA. Okay? Okay, if we had to prove it, we would just say, what are our reasons? Well, we're given some stuff, given that, oops, hang on, I skipped a different one? Yeah, I did. Okay, what about, so, we did do a proof, that's all right. What about this one? We're only given one thing. Actually, we're given some stuff. We're given a congruence, and it looks like we're given a parallel relationship. It looks like they're telling us those lines are parallel. So we got one thing, we need 2 more. What can we get? Okay, we got vertical angles, there's a second. We've got parallel lines cut by a transversal. So I could say that these are alternate interior angles, right? Does that make sense? If I choose those ones, what's the reason? Oh, ASA? Okay, what if I chose the other ones? Because I could also do that. Because those are also alternate interior angles. Now what would it be? AAS. So either one would work in this case. Okay? Make sense? We got out of here? I think that's it. Yep, that's it. We're good.